the scope of the test. So, while you're even working it out for the video, I'm going to be talking about it and working out the problem here. So these are notes. The video will be recorded for you. And we are recording, so let's start. All right. Unit 2 review. All right. First question. Given the domain D, and we have 2, 3, 5, 6, for the function, find the range. So some things to remember. If we have the domain, and we have this function, it's like our function machine. Okay? We put in our independent values, which is our x values. We know the domain is x values. And we're going to get a range. We're going to get some corresponding outputs, that is our y values. Okay. So it's just going to be plugging in one at a time to find, okay, we plug in 2, 2 goes in. What comes out through this function? We're going to put that value here. Put in 3, what comes out the function? So if I do f of 2, I get 3. If I do f of 3, I get 4. It looks like whatever we plug in for x, we're going to add 1, and that's going to be what we end up with. So I can go ahead and do f of 5. 5 and 1 is 6. F of 6, 7. All right. Dang it. Oh, shoot. Can't go back. Bummer. Well, this is the breakdown here. This was number 1 for the Kahoot. It glitched on me and went too far ahead. But if we look at number 1 here, we have the domain values, which are x values. Put it through the function machine. Whatever the x value plus is going to be plus added 1 to get our range, our y values. 3, 4, 6, 7. And I'm sorry, I didn't even get to see how many of us got it right. But the next problem is similar, so let's look at that together. Given the domain for that function, a little more tricky, the function machine's trickier, find the range. So look close, some of them are pretty similar. Okay, and if you weren't sure how to start, look at my screen here. That's how I would get it started. So here's going to be our process. We're going to plug in -1 to start, plugging in my x value to find my y value. All right, 5. And you keep doing that. That's f of -1. Now do f of 0. All right, actually, I feel like maybe I might have given away the answer. Not working, huh? Oh, man. All right, do your best. It's still a review. You could still write down some notes for the unit test. All right, we got 7 seconds. Take a guess. All right, pretty good. Were there any misclicks in there? Any misclicks? That's great. 16 out of 18, not so bad. So look, I plugged in -1, I plugged in 0, I got my first two y terms. I'm going to do this one mental math. Plug in 3, we get -6 plus 3 is -3. Plug in 4, we get -8 plus 3, -5. So this is what they want us to see. Remember, these are just our x values. These are our y values. Okay. And the way we remembered that is D is connected to X, R is connected to Y. Just like in the alphabet, D comes before R, X comes before Y. That's one way you could think about it. All right. Let's see who's ahead now. Okay. All right. Ooh, yeah. All right. Emily, Zinqui, and Brooke, Devin, and Madeira. Nice. It's very close. Very close. Whoa, very close. 4 points. What? All right, next. What's next? Double points. It's just a fun brain teaser. It's a riddle. What do we think about this riddle? I come from a mine and get surrounded by wood always. Everyone uses me. What am I? You only got 17 seconds. 15 seconds. These kind of like brain breaks are going to be quicker. 2, 1. All right. Hey, not bad. A pencil. All right, that's good. And a hammer, pick for mining. Those are reasonable. But, some of this isn't true. I come from a mine and get surrounded by wood always. But there's mechanical pencils, right? There's mechanical pencils. So I think this is like in 1982. I come from a mine and get surrounded by wood always in 1982. Everyone uses me in 1982. What am I in 1982? Okay, that makes more sense because it could be a pen. People use pens too. So this is just kind of like old school. A lot of these jokes are made by somebody that is older. All right, Emily taking back over Zinqui and Brooke and Nelson and Devin. Some people on the board that hadn't been. Very good. All right, back to this. Given the graph, what is f of 2? And this is number 4. Let's see. So I'll give you a hint. If I had, this is 1. If I was looking for f of 1, I would look to x is equal to 1. And I would say, where is the function when x is 1? When x is 1, the function is right there. It's not quite on the x-axis. So if I was looking for f of 1, I'd say f of 1 is about a half. So we're looking to see what the x value we plug in and what we correspondingly get for the y value. So what's f of 2? Where do I need to look for f of 2? I need to look here. I look to see what's going on at x is equal to 2. Because remember, function notation tells me what I'm going to evaluate for. So we're going to plug in x is equal to 2 to get our y value. This can be our y value. All right, go ahead and take a guess. I think actually this is the person that's a little bit locked out. So we'll go to 17 people and then we'll skip. All right, -3. So everybody peek over here because with this media, if we look closely, when I am looking at a graph and I want to know f of 2, I only need to go over for the x values over to 2 and see, well, where is the graph when x is 2? It's right there. You see? When x is 2, it's right there. When x is 1, it's here. When x is 0, it's up here at 1. right? So it's just looking to see, well, where am I 2 over for x? I'm right here on the function. So f of 2 is equal to negative 3. Okay. So let me do one follow-up question or problem for this. All right, somebody tell me approximately what is f of 1. Tell me in the chat for this function here. What is f of 1 approximately? Somebody in the chat tell me. I go over here to x is equal to 1, and I make a dashed line if that helps you visualize it. And where am I? Good, Lizeth. I'm right here, because that's where the function is. We're only looking at the function. If you're like, well, how did you know it was there? It's because this line's here. The line is the function we're looking at. And if I needed to know f of 1, I would look to see where the function crosses x is equal to 1. It crosses it at 1 for y. You see? We're not doing slope. We're not making steps. We're just seeing what's going on at 1. All right, what's going on at 2? What's going on at 2? Actually, I didn't do this. I'm going to do this. Oh, this isn't a correct function, but we'll make our dashed line. All right, where is the function when I plug in 2 for x? Let's see. Somebody tell me in the chat. Approximately, where is it? Yeah, good, Jacqueline. So here is where the function is at 2, and I look, and my corresponding y value is 3. Graphs are great. These are like, all right, good, Remy, good, Lizette. When you're asked to find what is f of 2, you just have to go to the graph and say, well, here's 2 for x. I go up, there's where the graph crosses x is 2. Boom, boom, boom. So I have an answer of 3. It's nice when we do that. I want you to see them as more straightforward problems that you can do, get some quick points for. Okay. All right, let's go on. I think the next one is similar. Let's see who's ahead. Oh, Zinqui, it's like, oh, Zinqui, Nelson, Nati on the board. Emily, Brooke. All right, Nati, you got to get first place, man. Let's see it. All right, number 5. Given the graph, what is g of 1? Same idea. Let me zoom in for you. Oops, too far. Too far. What is f of 1? Sorry, g of 1. G of 1. All right, go ahead and take a guess here. All right, so f of 1 is looking to see what's happening when x is 1. Where is the function right here where my cursor is? It's up there. What's the y value that corresponds? Right there. So let's see, we got 16. I think we got 1. Okay, that's it. All right, let's see. Whoa! Any misclicks in there? Any misclicks? Any misclicks? No misclicks? All right, that's fine. Yeah, anybody else? Do we get one more misclick? No. Okay, that's fine. You guys are getting the drift if only one of us missed it here, but for them, when we plug in x is equal to 1, it's crossing it right there. What's the y value that corresponds? 2. Yeah, those are going to be like freebie questions. if you understand what I was saying there, then that should come pretty quick on the test. Okay. All right, let's see. Oh, Zinqui taking it back. Nelson, not the Emily Brooke. Very good. All right, double points. This is just the brain teaser. If you have it, you want to share it. If you share it, you don't have it. What is it? Oh, yeah. There's one person that I don't think can answer, so I'm going to get to 17 and then skip. Whoa, yeah. Secret. A secret. Money. When you have it, you want to share it. That's cool, generous. If you share it, you don't have it, though. Just, be generous, but save some money for some food. And what was the other one? Personal space. Yeah, I can see personal space, but usually if you like personal space, you don't want to give it up so you don't have any, but I feel it. I know what you mean. Oh, but you got it right. Nice. All right, what's next? Let's see who. Whoa, Nelson on fire, taking over. Nice job. Nati Brooke, Zinqui, and Jade on the board. Nice. Oh, Nelson on fire. Jeez. All right, let's see. Is this an arithmetic, geometric, or neither? As far as it being a sequence, how do you go from 1 or from 0 to 1? How do you go from 500 to 100? Do you add a value or do you multiply a value or fraction? All right, let's see. Oh, geometric. How do you go from 500 to 100? If you thought it was arithmetic, you might have said, well, we're going to combine. We're going to add a negative 400. However, the next term is 20. Can you go minus 400 and get to 20? No. So that's not what it is. It is good. Not that you had it. We're going to multiply. Actually, not quite. Not quite. We're going to multiply. Well, the way to know this, remember, we can find our ratio. We can find our ratio by taking the next, dividing by the prior. Good, Nelson. So 100 divided by 500 is 1/5, which is 0.2. So what I know is I can multiply it by 0.2 to get to 100. To get to 20, I can multiply by 0.2, and so on all the way to 4. It's basically multiplying by 1/5, which I just expressed as a decimal. Okay? So we know because it has multiplication, it has to be geo. Geo is multiplying. Okay? So that's a good one. This next one is similar, so let's see if we can all get this next one, okay? Let's see what we have here. Yes. Jacqueline, if it helps you to think of it as you can just multiply or divide to go between them, that's fine. If you think of it as divide by 5, divide by 5, divide by 5, that will work. That's fine. However, when we express it, if we are then going to our next step and having to put our first term and our ratio of change, the ratio of change is in respect to how we multiply to go between them. So if you said right here the ratio of change is divide by 5 when we're creating our exponential formula, it's not divide by 5 because within this formula, we multiply these two terms together. So instead of divide by 5, we want to keep the integrity of it's already set up in the formula to multiply them together. So instead of divide by 5, I want to multiply by 1/5. Okay? It's just because it's related to the function. Is that? Yeah, good. Yeah, Nati, arithmetic is just addition. Arithmetic, think of it like you learn arithmetic, right? You learn arithmetic in like first or second grade, and that's easier. It's the addition, it's easier stuff. You learn geometry later. Geometry is multiply, just like you learn multiply later. Does that help to remember it? All right. All right. Number 8. Same question. Arithmetic or geometric? How do you go from 3 to 9? Does the same process work from 9 to 15, from 15 to 21? And does that tell you if it's arithmetic or geometric? I think we can all get this, guys. Come on, let's do it. Ooh. Misclick. Yeah. All right, unmute, power clap. Unmute, 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 unmute. Everybody, everybody. Unmute, unmute. All right, power clap on 3. 1, 2, 3. Oh, I love it through Zoom. Awesome. It is arithmetic because how do we go from 3 to 9? We add 6. 9 to 15, add 6. 15 to 21, add 6. So the common difference is 6. And it has to be arithmetic because we are adding a value to get to the next. We're not multiplying a value. Okay. That's going to boost everybody. What? No one changed? Oh, okay. Just kidding. I think everyone just boosted. All right, double points because it's just not the last rebus. It's not the last rebus. Okay, what do we get? Oh, pretty good. Try to understand. Try to is understand. Try to understand. That's going to change some scores, I'm guessing. So 15 out of 17. That's pretty good. Let's see. Did it change? Oh, Jada said, yep. I'm taking over third place. All right. It's pretty close between these 5 students. All right. Write the recursive formula for the arithmetic sequence. So this is where, look at my, well, you don't have to look there. You can look here. Awesome. So we told that it's an arithmetic sequence, which is addition. So I want to write a recursive formula. I want to write this type of formula for these values. Negative 23, negative 19, negative 15, negative 11. Okay. Let's see. We're told this is a sub 1, this is a sub 4. Here's all I need for the recursive. A sub n is equal to a sub n minus 1 plus d. The only thing I'm really plugging in is my common difference. So your question that you ask is, how do I go between these? We're already told it's arithmetic. They said that. So essentially, once we figure out what the common difference is, we plug it in there and we're done. So I'm going to go ahead and just get it ready for that. All right. So looking at this, pretty good, pretty good. We had 23, negative 19, negative 15, negative 11. We know that we're going to be creating a recursive formula from that information. So we're also told it's arithmetic. So I look at my formulas here. Recursive to find the next term is a sub n is equal to the prior term plus the common difference. How do you go from negative 23 to negative 19? If you're underwater 23 feet, you end up at negative 19 feet. You've gone up 4. Negative 19 underwater, you go up 4, you're only 15 feet under. Negative 15 under the water, you go up 4, you're at negative 11 under. So we know that it's plus 4. Done. All right. Ooh. Whoa. Dylan on the board. All right. All right. What's this one? Okay. Write an equation for the nth term of the arithmetic sequence. So this was number 10. Now we're looking at number 11. So any term, I know that I'm talking about creating an explicit formula. So I'm going to go ahead and write this for number 11 here. I need to look at the sequence and figure out. We're told that it's arithmetic. So I want to create this type of formula. It's going to be helpful. We know this is a sub 1, so that's going to go here. What do you do to go from negative 10 to negative 6? Underwater 10 feet. You end up at negative 6 feet. How far up did you go? Plus 4. Plus 4. Plus 4. So I know that my d value is going to be 4. Now, if I distribute it and simplify it, I'm done. And there it is. Okay. All right. So just going through what I just went through here, we have negative 10, negative 6, negative 2, and 2. The common difference between it is we add 4. We add 4. We add 4. If you couldn't figure that out, you could do negative 6 minus negative 10. That ends up being 6 plus 10. That ends up being positive 4. Okay. So you can always go and look and find the next, subtract the prior, and that's how you'll find your d value, your common difference. It's just saying how much do you have to combine and add to the prior term to get to the next term. Weird, Remy. So what I did was I wrote down the explicit formula because we were looking for finding the nth term, any term. And what I plugged in for a sub 1 is negative 10, n minus 1 times 4, distribute, simplify, 4n minus 14. They put it this way, but that is the same thing. I just think that's a weird way to write it. So do it in descending order. Put all the variables first, working your way down to the constant, and that's how we're gonna approach it every time. Oh, Brooke moving up. All right, no need to answer this. This is our breakout room experience, and the way this is going to work is I'm going to throw you into the rooms. When you're in the room, you are going to be doing, the picture scavenger hunt. Okay? So with the picture scavenger hunt, picture of you in a costume, picture of your pet, picture of someone dancing. It could be you dancing, it could be someone else. So for instance, here is a picture of, let's see, what do I have to show? So you're going to look on your own phones for these. So maybe jot these down, and then you're going to go ahead and share it with your group by holding it up to your camera, which hope you don't get too much glare. You got to kind of tilt it. See, and there's my dog, Rogue. Yep. You can see her a little better there. Oh, she's so cute. So this is how we're going to do it. Now, if I show a picture of my dog, I get 1 point for the team. And in the next slide, you're going to say how many you got total from everybody in the team. So in your group, find all the items listed. Listed. Listen. From the pictures on your phone and show it to your group by holding it to your webcam. Stay in the breakout. This is important. Stay in the breakout rooms until the time is over. So when I close the rooms, there's still 60 seconds. Stay till the time runs out. Keep track of the number of items all of you find. So you could end up, if you have 5 people, you can end up with 25 points. So I'm going to open the breakout rooms and go ahead and get your camera or your phone out so that you can look up some pictures, and you are going to share them as we go through it, okay? All right, here we go. Stay in the rooms till you're done. Once everyone gets in the room, you could start. But you can start looking now for those 5 different things. Selfie bomb, picture taken at any school, picture of someone dancing, your pet, or you in a costume. All right, opening the rooms. I'm going to go ahead and start sending you in the rooms. And it will take a moment. There is no room 7. So you are going to be room 3. All right. And everyone, go ahead and join the room. So Zinqui, go ahead and join the room that you should have an invite to. And I'm actually going to move you guys to another room. Let's put you in one. All right. So since you guys at home aren't able to do that, here are the arithmetic and geometric sequence formulas. So make sure you have those written down, ready for your unit assessment. So we still have another 50 seconds till they get out of the rooms. Somebody came back soon. All right, Nati, we're supposed to stay in the room the entire time. So I can't put you back, unfortunately. All right, no worries. While we're waiting, you still have another like 30 seconds. Oh, you don't have fun. Okay. I'll think of options for that for next time. Maybe like show something in your room, like show and tell. Make sure you have these notes down that I have on the video camera right now. You definitely want to have those notes handy. You might already have them. All right, they're going to come back in 2 seconds. And we're all back. Cool. All right, all right. Hey guys in the chat, let me know right away. How did that go? Let me know on a scale from 1 to 5. 5 being amazing. 1 being nah. I'll have an option next time if you don't have a phone. All right, hey, 4s. 4s ain't bad. All right, we are going to look at the next slide has where we're going to vote. Only one that did it. What? What are you guys doing? Guys, you got to participate. You got to participate. I might have to go in the rooms and make sure next time. But it's still good. A lot of you guys got some 3s and 4s for that. But you guys participate a little more. Okay, you're gonna write down or choose the number of picks did your group find total. So everybody kind of, estimate how many you guys showed each other. Did you just have 1 to 5 total? 6 to 10, 11 to 15, 16 to 20 plus? That's a lot. All right. So quite a few folks just had 1 to 5. Okay, I think we had a couple slower groups, and there's one person that claims over 16. Just one person. I like that. All right, let's see who's on top now. Nati taking over. Dylan Nelson. Brooke Jackie on the board. Nice. All right, what's next? Find the explicit formula for the sequence. Explicit formula. First, you got to decide, is it geometric or is it arithmetic? Are we adding or multiplying to go between them? To me, it looks like we're adding. So I'm going to go ahead and cover up arithmetic or geo. I'm going to stick with arithmetic. So we're trying to fill in an explicit formula. If we know the first term, which we do, we put it here. If we know the common difference, we put it here and distribute, simplify, and you're done. So let's see. How are we going between these terms? Underwater 18 feet, you end up at negative 22. What you're adding to this is a negative 4. That's important. We're trying to create an explicit formula for number 14 here. A sub n, a sub 1 plus n minus 1 to the n, d. So fill in what we need in order to complete this. We keep the n involved and we put in the rest. A sub 1. Negative 4. All right, 10 seconds. All right. Hey, not bad. Not bad. At least we reduced it to 2 different options here. Let's see what those options are for C and D. Yeah, that's just a little bit of an adding error. No problem. Actually, I think it's a distribution error. So look, I put in my terms. I know that I'm subtracting 4 every time. So my D value is -4. I know my first term is -18. That's why I put it here. My D value is -4, so I put it here. Now I have to distribute the -4. This is where the error happened, I think. Look, we have -18 plus -4n, because -4 times n is -4n. -4 times -1 is +4. That's what happened. Or actually, I don't actually know how you got -18. I think it was just a little error. All right. Maybe you got here and you're like, done. But we have to combine these two. And that's where we get our -14 minus 4n. Which I really wish they didn't write it that way. Descending order is always better. So this is better than that. Oh, misclicked. All right, there's a couple misclicks. That's good. That's good. Redeeming. All right, let's keep on going because we have another 15 minutes and we still have at least 4 more questions. Nati holding down. Nelson, Dylan, Brooke, Jackie on fire. All right. Write an explicit sequence. Oh, that looks like it might be arithmetic. How are you going between those terms? How do you go from 1 to 7? How do you go from 7 to 13 to 19? What do you have to do? 1 to 7. Let's see if it works. Plus 6. You can experiment. 7 plus 6? 13. Yeah. 13 plus 6? 19. So my common difference is 6. My a sub 1 is 1. That's all you need in order to create this formula. Plug in here, reduce. So we just got to plug in here and here. Okay, do this, simplify, and you're done. All right. All right. All right. Most of us got it. Misclick, misclick, 2 misclicks. No. All right, look. Now, a sub n is equal to 1 plus, distribute it, 6n, distribute it, minus 6. How did I get that? I had to look to see what's going on between these numbers. We're adding 6, so I know it's arithmetic. We're trying to find explicit formula. That's why I rewrote it right here. But from this, I knew that your d value is 6. That's a common difference. Your a sub 1 is the first term. So that's all I need to input. A sub 1, d, distribute that 6, get to this step, finish it. Finish him. So we get minus 5 plus 6n, aka 6n minus 5. Okay, so that was number 15. Okay, correct a little bit if you had a mistake in there. Okay, and let's see who's ahead now. No change. What? No way. All right, double points. I think this is just a rebus. What does it mean? What does this rebus mean? Ah, back to square one. Let's see. You had to pick the idiom, the figure of speech. Back to square one. And if I look at this, they wanted you to say the word to, not a number to. Okay? Just because they're going to give you the answer that is the figure of speech, which wouldn't have a to right here. Okay? 11 of us got it. Maybe that's going to boost someone. It's double points. Nelson. Nice, Nelson. Nice. All right. Let's see. This one is a different topic. What is the rate of change over the interval? Okay. So this one is different than our sequences. I just want to remind you that the rate of change is our slope, which is that one where it's y sub 2, y sub 1, x2, x1. So the interval, -2, 1, this is our lower limit. This is our upper. These are x values. They basically gave us our domain between -2 and 1. So first off, these represent 2 points because these are both x values. The lower x value is -2, the upper x value is 1. So once I figure out what y value goes with -2 from the graph, what y value goes with +1 from the graph, then I could label them and plug them into the slope and find my answer. So look on the graph. What is the point for -2 for x? Find -2 for x. Where does the graph cross -2 for x? Crosses at 4. When x is 1, where does the y value cross it? 0.5. All right, we definitely look at this one more. That's weird. Okay, it's weird. So look, the rate of change is our slope. The slope can be figured out from 2 points if you have a y2, y1, x2, x1. Because 2 points, here's really our graph like this. It's like this. Okay, here's our graph. And what we're looking is to see, well, what is the rate of change between -2 and 1? That's what our interval was. So what I'm looking at is, I'm looking to see, well, what is my slope between this point and this point? The rate of change is just the slope between 2 points that, in this case, are the edges of the interval, lower limit, upper limit, boom, boom. Okay. So look, this point up here was -2, 4. That's why I put it here, the lower limit there. And the upper limit is 1, 0.5. So look, I got the 2 points here from my lower upper limit from my interval, and I'm just going to label them. And I'm going to plug them in there. And I'm bringing it down here so we can see it. Let's see. Let's just reduce stuff first. 1 plus 2. And that equals negative 3.5 over 3. So my slope is negative 1.6 repeating. Boom, boom, boom. All right, give me a thumbs up, sideways, down after you see that once. This is actually important. I need to know. Thumbs up, thumbs sideways, thumbs down. Yep, in the middle. Okay. The next one is similar, and there's a few of these on the review assignment, so you will have a chance to try it again, and we'll go over it. Okay, we'll go over it in class for the start of the class. All right. Ooh, no change. Everyone just went up. What? Or down? All right, let's see. Find the average rate of change from over the interval. So think about it. Now we have, instead of a graph, now we have a function. So here's what we're going to be doing. We know we have the interval negative 1, 4. With this, what we know is this is the lower limit and the upper limit. So this is really a point, negative 1 something. The upper limit is going to be 4 for x, something for y. So the way that we're going to figure out what the y value is, we're going to put it through our function machine. Right? I'm going to plug it into the function that gave me to find my y value. All right. If you're not sure how to start, peek up here. We had the interval, lower and upper limit. Split them up, put them in for the x values because the interval are our x values. Interval are x values. I plug in 4, I plug in negative 1, I find my y value of 3. I find my y value of 28. All right, don't worry about that. So now I have my points. Now I'm going to find my rate of change. So all this work was plugging in our 2 interval values into our functions to find the corresponding y value. Now what I need to do is plug in to the slope formula, and I'm done. x1, y1, x2, y2. (28), 3, y2, y1, x2, x1. 25 over, that's going to end up being plus over 5. So my slope, the rate of change is 5. Okay, I'm going to zoom out so you could take a screenshot of this guy. All right. Go ahead and screenshot that if you like in 3, 2, 1. And the last 2 slides were some funny videos, but it's 10:50. So we're going to see who is the winner of the game once and for all. Who do we have? Hello? Oh, the podium. 3rd place. Nati on the podium. Good job. 2nd place, Dylan. Dylan, 1st place. 1st place, Nelson. That took forever. All right, runners up, Brooke, and it couldn't see who the last person was. That's fine. All right, guys. Thank you for joining me for another installment of What Are We Learning Today? Come on, stop. My computer's wigging out. Get over there. All right. All right, guys. Stop. Fine. You lose. Get out of here. All right. Thanks for joining, and I will see you on Friday. Okay? Have a good rest of your Wednesday, guys. Take care.
Have a nice rest of your day. Thank you.
All right. Take care. Thanks.
Can I ask a question like always?
Yeah. Let me stop the recording 1 sec. Come on. Hello? There we go. Stop.